Today, I invite you to travel with me to South Central Kansas and discover a region of buttes and canyons, a landscape very different than what we usually associate with Kansas. In the Gypsum Hills, also known as the Red Hills, the rocks and soil are stained red because of the iron oxide, or rust, that covers everything. But why is the relief so different here? How were these rocks formed and what can we learn from them? Stick around and let's find out in this Geonuggets.
Hi, I'm Dr. Karen Goldberg with the Department of Geology at K-State, and today I invite you to visit with me the Gypsum Hills. This location is in southern Kansas, and as you can see from the background here, it's a badlands where you can see these red rocks. The scenery is pretty beautiful in this area, but the geology is even more interesting. So come with me and I'll show you some cool rocks and what these red rocks are all about.
Looking closely, we see a stack of red shales and some white layers. These rocks were formed about 260 million years ago, during a time when the climate in Kansas was very different from today. So in this outcrop, we can see the kind of rocks that form the Gypsum Hills. And behind me, you can see that most of it is this red mud rocks. These are siltstones and mudstones, and every now and then we see these white layers, and these are gypsum layers, hence the name the Gypsum Hills. The gypsum is a mineral that we call evaporite, exactly because it forms under highly evaporative conditions. So the water has to evaporate out a lot in order for the salt to be concentrated enough and precipitate out. It's basically the same thing that you get, for example, if you get a glass of water and you add a scoop of salt and you mix. In the beginning, you can dissolve all the salt in the water. But if you keep adding salt and mixing it in, at some point, there is so much salt that the water cannot hold the salt anymore, and it starts to precipitate at the bottom, and you form this layer of salt at the bottom just because it's super saturated. It's overly concentrated in salt, and the water cannot dissolve it any longer. So it's the same process that happens here to form the gypsum. If you evaporate the water out, it's kind of the same end result. Too much salt for that volume of water, and the gypsum precipitates. Gypsum is calcium sulfate, hydrous calcium sulfate. So the calcium that is dissolved in the water joins with the sulfate to form this mineral and precipitate at the bottom. These red beds, as we call them, were formed in very arid environments. Think about, for example, Nevada today. Very arid environments where we have the deposition of wind-blown dust. We have the formation of some ponds that have water during a short period of time, and then the water evaporates out. And all the salts that are dissolved in the water, they get supersaturated and they precipitate out of the water in the bottom of these little ponds. And the fact that you have several layers of gypsum is telling us that this is probably an ephemeral and repetitive process of wet and dry in this overall arid environment. Now, the gypsum has very cool features. It can crystallize as prisms like this. It forms this really semi-transparent features here, and you can tell it's gypsum, not quartz, because gypsum is very soft. It's hardness 2 in the Mohs scale, so you can scratch it with your fingernails. Quartz, you cannot do that. And interbedded in these red beds, every now and then we find some fine sandstones like this. And as you can see here, we see some undulations on top of this bed, and these are ripples, ancient ripples. So this is the record of some agitation in the water, forming these tiny waves that wave down the sediment at the bottom of the lake.
The butte and mesa topography was influenced by the gypsum layers that capped the hills. They are more resistant to weathering than the underlying shales and siltstones, so they protect the less resistant layers below. So the Gypsum Hills tell the story of when Kansas was a dusty desert covered by saline lakes here and there. Something hard to imagine in a place that today is part of America's breadbasket. Another interesting thing about these rocks is that they are considered to be Mars analogs, meaning that based on the data and images made available by NASA, it is possible that the rocks in Mars are similar to this and therefore deposited in a similar environment.
So we can study these rocks and have a sense of what we should encounter in Mars. Well, we are only going to know if that's true once the samples that are being collected in Mars are retrieved and come back to the Earth. But this is the kind of work that the geologists do, try to find an analog, something that we believe is similar to other planets on Earth, to study and be able to understand the formation of Mars as well.
The beautiful red hills were known as the medicine hills to the Indians, who believed that spirits in the hills and streams helped to cure illnesses and prompted the healing of wounds. They were on the right track actually, as these contain calcium and magnesium sulfate and other natural salts dissolved from the abundant gypsum and dolomite deposits in the region. I hope you enjoyed our trip today and had fun learning about this unique place in the heartland. See you next time!
Shut up and sit down.